Good evening, all. Thank you for joining us this evening for our virtual information session. Now that life is slowly returning to some normality, we really hope that we get to meet you all in person soon. But for now, we hope that you find our online session, informative and helpful. Without further ado, I would like to hand you over to Professor Glen Bright, who is the Dean and School of Engineering. Professor Glen Bright.
Yeah, thank you very much, Ms. Maney. My name is Professor Glen Bright, as has been said, and I want to give you a very warm welcome to this session, this Careers Open Day session. Welcome to the parents, welcome to the boys and girls, and we're very happy to be able to address you. In terms of asking questions, comments and queries, we have the chat box. So you may put a question in there at any time in the chat box. Please use the chat box, and we will then, of course, allow you to have those questions, and we can address those questions as we go along. Or at the end, if we haven't addressed it, we can relook at that question again. So please use the chat box as has already been used. So, very happy to have all of you, and I'm very excited to be able to address you today as the Dean and Head of School of Engineering. In engineering at the University of KwaZulu-Natal, we have 4 clusters. And the 4 clusters of engineering consists of cluster number 1 is your civil engineering, your agricultural engineering, and land surveying. We call that cluster 1. Then the cluster 2 is the electrical, electronic, and computer engineering. And then the 3rd cluster is chemical engineering, and the 4th cluster is mechanical engineering. So essentially, we have 7 engineering disciplines to be found, and you can study those. And of course, we have land surveying as well. Now, the question on everyone's mind is, number 1, should I take engineering? Okay. Now, for some people who have already made that decision, well, then it's easy, you can make the next step. But for the others who haven't made that decision, let me just give you some information for you to consider. There is no doubt that engineering makes the world go round. When you look up in the sky and you see an airplane flying, those are engineers that make that airplane flying. I'm sure you've wondered, if you don't know already, what keeps that airplane flying? How can it fly? How come it doesn't fall out the sky? When you jump in a car or in a motor vehicle, that's been designed by engineers. When you see a train, when you use your cell phone, when you use any appliance, it's been designed by engineers. When you have factories, when you have railways, that's been designed by engineers. So engineers are crucial to an economy of any country. Okay, almost everything you use, okay, I can say almost and probably everything you use has somewhere along the line been designed and manufactured by engineers. And that's why engineers are so important to an economy of a country. So once you've made that decision that you have an interest in why things work, how things work, then the next issue is, well, where should you study? Now, we realize that there are many institutions in South Africa where you can study engineering. And of course, you can go abroad and study engineering. And of course, one's choice is taken as you want. What you need to consider is something called accreditation. It's very important that you study a degree that is accredited. Now, it's not the university that's accredited, it's the degree that's accredited. So you must just be clear in your mind about that. That degrees get accredited, and degrees get accredited by professional organizations. The professional organization that accredits engineering degrees and technologies in South Africa is called the Engineering Council of South Africa. We call it ECSA, ECSA, which of course are the first letters of the Engineering Council of South Africa. So that's the professional body that accredits engineering. So when everybody says to you, well, is a degree accredited? The first question you ask yourself, well, who's the professional body? A degree can't be accredited without a professional body. You can't wake up one day and say, well, now my degree is accredited. Or if somebody says to you, a degree is accredited, ask the question, well, who's the professional body that's accrediting it? So in engineering in South Africa, the professional body is the Engineering Council of South Africa. All degrees in engineering at UKZN are accredited by the Engineering Council of South Africa, and that Engineering Council of South Africa is a signatory to the Washington Accord in the USA. This is the highest accreditation body that one can use to accredit and evaluate degrees. And UKZN, all degrees are accredited. Now, that's very important. That means if you're studying at UKZN or any other university around the country, it's important to know, are the degrees accredited? Because if they're not, then what happens is you possibly could get an education and find yourself going to the job market, and in the job market not wanting to accept the degree or certificate or the technology that you've gone and studied for and spent many years and spent a lot of money. So the degrees in engineering at UKZN are all accredited through the Engineering Council of South Africa, signatories to the Washington Accord. Okay, next thing is, what about my career? Yes, I get my degree, and now what career I'm going to do? Well, of course, as I've mentioned before, the world goes round because of engineers. You can go into design, which means you're designing apparatus, motors, rockets, aeroplanes, factories, etc. But of course, it's also about your quality of life. Now, engineers are on high demand. In almost all countries in the world, there's a shortage of engineers. What's good, because our degree is fully accredited, it means you can go anywhere in the world and you can get a job because our degree is accredited. So it's not that you come from South Africa and they say, well, no, we're not going to give you a job. They'll say, who's your accreditation? You would tell them, and therefore a company or university would accept your degree, the standard of degree, because of accreditation. But a career in engineering is very rewarding. It's a bit about designing, it's about building, and it's about something actually working. And that's where engineers make a huge significance to a country. Because what does a country want? Countries chase wealth, okay? The more wealthy the country, the more the country can look after its citizens and pull the citizens out of poverty. So wealth generation is very important for countries around the world. And you can look at examples of Western Europe, the USA, Japan, Sweden, Norway, the wealthy countries of the world. Why are they wealthy? Well, of course, they have a lot of engineers. A lot of engineers building infrastructure for the country. That infrastructure varies from railways to airports, to aeroplanes, to ships, to cars, to trains. Engineers create wealth for a country, and that's why they're in such demand. So a career in engineering is very, very sought after. It's very rewarding. And of course, yes, financially, it's very good as well. You'll earn a good salary as an engineer for the rest of your life, as long as, of course, you practice in good faith, you have good governance. You'll earn a good salary. Of course, you'll probably have a family along the line, and you'll be able to provide for your family more than adequately. So that's the third reason. The next thing I want to go through is the curriculum. Now, over the years, curriculums have changed because of the advancements of technology. Technology is specifically related to computing, of course, software design, and the impact of that. Now, the curriculum of UKZN in engineering specifically has gone through and is going through a transformation phase at the moment, where we are aligning our curriculum to the fourth industrial revolution. Now, that's important as well. It's no use studying an engineering curriculum where in a curriculum, your curriculum is outdated and you get into the marketplace and you find that you're overwhelmed by the kind of technology and the kind of issues that you're dealing with. So UKZN engineering curriculum has embarked on a major transformation, strategy and execution. And we are currently completing that, and we'll have it ready in the next year or so. It's already been rolled out in chemical engineering, and it's currently been rolled out in the other 6 disciplines. So our curriculum is going to be up to date with the fourth industrial revolution, and we are now confident that we're going to provide you the best up-to-date curriculum that's available for engineers. So with all that, one has to decide now that this is a career that you want to go for. Yes, of course, you do need to be strong in math and science. Mathematics is important and science is important. Why? Well, of course, because engineers model things in mathematics. They simulate things. Because the days are gone where you just go build a bridge or you build a vehicle or you build an airplane and you hope it flies. We model it, we simulate it, we see if it's going to work first on a computer, and then, of course, we go and build it. And for that, of course, you need to be strong in maths and science. Along with that, then you're able to code algorithms and carry on. So we have a web page on the UKZN site. So I'd invite you to go look at the UKZN engineering web page. It's easy to navigate to. You just need to go to the web page, go to colleges, select on engineering, and you can see the projects that we embarked in. Now, I can tell you as the dean, we have a very competent staff. Our staff, many of them are professional engineers. Others are moving through the system, becoming doctors and associate professors. They are very motivated. And that motivation can be reflected or seen in the projects that we are embarked at the moment. Some highlights: we have recently created the Rocket Institute, where we are the only university in Africa at the moment to be launching rockets down in the Western Cape. We have a pollution and research group, which is now an institute as well. We have waste management. We have various chemical projects and electro-electronic engineering. We have projects which are involved with Eskom. So we cover a wide range of projects. So the project's the exciting part of engineering. You go through your 4-year degree. It is a 4-year degree. It's an honors degree. And yes, it's fairly difficult, the subjects, and you get through them with some mini projects, mini assignments. But then at the postgrad level, at the master's level and the PhD level is where you can really contribute to the science of engineering by applying the knowledge you got from the previous years and being part of these exciting research groups, which are not only based in South Africa, but they have members worldwide. Their work is presented at conferences internationally, and their work is also published in international journals. So we have a highly internationalized group. We have a highly internationalized engineering program, and we're part of a world-renowned university. So with that, I've gone through the importance of engineering. I've gone through the accreditation. I've gone through what a rewarding career it is. And I've gone through also just some of the little bits that are required, the strengths in maths and science in order to do engineering. With that, I would like to end that. Now, I see there's a whole lot of questions already in the chat box, which I can address. I will do that once I go offline. But now what I'm going to do, I'm going to hand over to the head or the academic leader of civil engineering, because today we are focusing on civil engineering, agricultural engineering, and land surveying. If you're interested in the other engineering degrees, of course, tomorrow we have our electrical, electronic, and computer engineering. On Thursday, we have chemical engineering. And on Wednesday, we have chemical engineering. And Thursday, we have mechanical engineering. You can have a look at the program. But every day we'll start at 17:50 or 5:30. And then we'll go on to around 7 o'clock or 6:30, depending how long it takes. So you're welcome to join the sessions every day if you're not sure. Or you're welcome to join the sessions where you have interest in. Just a last point, it's also very important to talk to your parents about your career. Parents, of course, also have their set ideas on what their children should do. And it's also a good idea to express to them if you like engineering, what's good about engineering, what excites you about engineering, and the university or UKZN where you might be going. Your parents are also welcome to contact us. They can contact me directly as the dean. I'm available, or they can contact us through the PR department, through the normal channels, the web pages and that. So we operate an open door policy at our university, specifically in engineering, and the lecturers, myself as the dean, the academic leaders, and the PR department are more than welcome to answer queries either tonight or other times if you have any questions. If you have any frustrations with registration or you have any issues in terms of feedback, you're also welcome to contact us. We're available. Basically, as long as there are light hours and we are awake, we are available. We're there to help you, and we want to get you to come and enjoy engineering and walk the path with us. With that, I'm going to hand over to the academic leader of Civil Engineering Cluster, Professor Mohamed Mostafa, to take us further. And thank you very much for listening to me, and I wish you well. Thank you.
Thank you so much, Prof, and good evening, everyone. Welcome to the parents and students and let's say our future students in the near future. I am Mohamed Mostafa, the leader of this cluster, which comprises agricultural engineering, civil engineering, and land surveying. So just a quick information on the UKZN system, which is a little bit different from the other universities. We have the College of Agriculture, Engineering and Science, and there are 3 other colleges in the university as well. The School of Engineering is part of the College of Agriculture, Engineering and Science, where we have other 8 schools, including the science and of course the agriculture. Then under our school, there are clusters. One of them is the ACL, the Agriculture Civil Land Surveying Cluster, where we have the 3 different programs, the civil engineering programs, the agricultural engineering, or what we call also bioresources engineering, and the land surveying, or what is known also as geomatics. So the Dean informed you about why do you study engineering, how engineering is important to any nation and to the world. So what do you need to have to study engineering? You need 33 NSC points. You need 65% at least in both math and physics. This is why Prof. Pride put emphasis on how math and physics are very crucial to an engineer. And you need to have at least 50% in English, either as first or as a first language or first additional language. So we wish you all well, and we wish you that you achieve these levels, and then you join us. When you join us, this is our building in Howard College. And agricultural engineering is based in Pietermaritzburg. So what do civil engineers do? Civil engineers do the civilization services. So everything, since you wake up in the morning at your house or flat, going out to your work, going through a tunnel in your travel, going to school, going to shopping, going to services, airports, dams, bridges, underground structures, harbors, all these services are built by civil engineers. So civil word is coming from the civilization, because basically what they found that there is no civilization to be built without the civil engineers. If we go back to the Romans' time, the Pharaoh's time, it was all about building. And this is what made these old nations great nations. So we contribute to civilization through solving complex problems. So when you join us, we teach you step by step how to arrive to a point where you solve complex problems before you graduate. And these are just examples of these complex problems. The Sampton Towers, the Spaghetti Junction here in Durban, and other projects. So every day we are building in this country for the people of the country as citizens of South Africa or people residing in South Africa, while we are doing the same as civil engineers all over the world. And as Prof. Pride mentioned, our degree is accredited by the South African Engineering Council, and because this council is part of the Washington Accord, it is directly, automatically accredited by most of the countries in the world which are part of the Washington Accord. So the main fields of civil engineering are structural engineering, transportation engineering, geotechnical engineering, environmental, and water resources engineering. So we don't specialize under the civil engineering degree. You study all these areas, but you specialize in your last year doing your design project. So to graduate, you need a design project. So you take one of these as a design project. However, your degree will still be in civil engineering. You will have enough information in every single area, which will help you to work in any of these specialized areas. Now we are in a world where multidisciplinary became very important. No one really works in isolation. Everyone is working within a team. So basically, this knowledge is very important, and we add complementary studies to these knowledge. And as Prof. Bright mentioned, we are under a process of reviewing our curriculum to update it to meet the fourth industrial revolution requirements. And in civil engineering, we are quite ahead in this project. Agriculture and land surveying are also in the process. So you are going to study an updated curriculum, and it's very relevant to industry. We have very good relationship with industry. Every program do have industry advisory board. They meet on annual basis to discuss the progress and the developments in the field and how these progress and developments can be implemented in the study. So this connection is benefiting undergrad students as well as the postgrad students. So the bioresources engineering or agriculture engineering, it's in Pietermaritzburg campus. It's a unique program in the country. In fact, there are very few in Africa and all over the world. So it's a very, very important and not well-known degree. It's very crucial. It's a very scarce skill as well, but not a lot know that there is something called agriculture engineering. And it's about the engineering services to help the agriculture. So basically, bioresources engineers, they connect the living world of plants, soil, water, and animals with technology. So the farmers and the agriculture scientists, they have their own area of interest in the plants, the soil, and the water, the animals, but not the technology. We are the technology part. We are connecting all these elements together using machinery, using technology, using engineering systems to make the life of the farmers and the agriculture scientists easier, so that the life of the people also becomes easier. So bioresources is the middle point between agriculture in general, environment in general, engineering in general. So it's the overlap between those three general sciences. So anyone who studies bioresources engineering, of course, by default, engineering is main part of what they do study, but of course, they are also introduced to environmental studies and agricultural studies. So their knowledge becomes vital in the agriculture industry. Geomatics or land surveying, it is based also in Howard College in the same building with the civil engineering. And they work with acquisition, processing, management, presentation, and dissemination of geo information. So basically, to build any of these infrastructure we were talking about earlier, we need information about the site. We need information about the earth where we are going to build. We need information about the topography of the area. So the land surveyors are doing a great job in terms of preparing for any project. So they study a lot of areas like cadastral surveying, engineering surveying, global navigation satellite systems, geodesy photogrammetry, remote sensing, hydrographic surveying, and GIS. So it's all about using new technology in serving the land to get information which can help the engineers to do their designs. And it's not only about the land, they also go through the water, so they can get information about the rivers, the oceans, and so on. And they use new technology like GIS, for example. So in terms of what can you do after you graduate from any of those three programs? You can work for the government in the departments, Department of Transport, Department of Agriculture, Department of Human Settlement, and so on, or in the municipalities. You can work for companies like Eskom, Transnet, Sanral, and so on. You can work in an engineering company, and we have very famous big engineering companies working in South Africa. And sorry, most of these companies do have good relationship with us. As I said, they are part of our industrial advisory board, and they are in collaboration in terms of research activities as well with our colleagues. You can work in construction companies. The difference between the two is the first one, they do the design. And the second one, they do the construction. So you as an engineer, you study both the design and the construction. So when you graduate, you know how to plan, how to design, how to construct, how to build. So you can work in the design side or the construction side. Of course, a lot of engineers, they move between the two. So they start their career in one side, they move to the other, and then they move back or so on. You can also work like us in academia and research. So you can work for a university, or you can work for CSIR, or any of the research institutions in the country. Or simply, you can have your own company. So also part of what you learn is some entrepreneurship skills, some information related to economics, management, and so on. And these help you to start your own small company, and maybe one day you will have a big company to be added to the list of those big companies up there. Why UKZN? First of all, we are here next to you in Durban, and we are accredited. We are part of, as we said, the Washington Accord for engineering, and we are part of the Plateau SAGC for land surveying. So you are going to graduate with an accredited degree. We have a very highly qualified team. Over the last few years, we went through a development program. We extensively recruited a lot of staff to fill in the vacancies, which were vacant for quite some time. So we have a diverse profile of academics with national and international experiences. So we have young lecturers who are very dynamic and very motivated to build their career. We have experienced professors who do have a lot of either local or international experience to share with the students. So the staff profile is very appealing and very helpful for a student. We also have excellent connection with industry. And we over the last few years, we tried to strengthen that relationship with industry, so that when we develop the new curriculum, it is aligned to what industry needs. So we always talk with them. Today, we had a training with one of the companies which provide civil engineering and land surveying software. And the training was for our staff to know what is new in the area, what has been developed recently as tools And then we discussed how to implement these tools in our curriculum. So we are trying to keep that link with industry, so our graduates are prepared as much as possible for the market. We also have excellent laboratories. So our laboratories went through upgrade process, and most of the laboratories are now very much world-class in terms of ability to serve research, and of course, by default, to serve undergraduate students. So the needs for the undergraduate students is fully covered, and there are a lot of equipment which are related to research and to new developments in the area, and we use these for our undergraduate students as well. So we prepare them for something which will happen in the next maybe 5 to 10 years after their graduation. They have hands-on equipment which most of the universities don't use for the undergrads. We also, and most importantly, we inspire greatness. We need our students to not to graduate only, but to graduate with high marks, to graduate with a lot of knowledge. So we support them as much as we can. So that's the end of my story, and I hope that I can see you in person joining one of our programs in 23, and let's help each other to build the future of our young kids. Please feel free to contact us. These are the websites the Dean was referring to earlier, and the emails of the administrators of each of these programs. So you are most welcome if you have a specific question which is not answered in the chat today, to email your question to the concerned program administrator, and it will be directed to the right person to answer you. So that's the end of my presentation. Thank you so much, and I hand it over to Prof. Kumarasamy, the Program Coordinator of Civil Engineering. Prof. Kumarasamy, over to you.
Thank you, Prof. Mustafa. Good evening, everyone. I'm Prof. Kumarasamy, Program Coordinator for Civil Engineering Program. As Prof. Mustafa mentioned, that Civil Engineering is one of the 8 programs in the School of Engineering. Civil Engineering is a profession that deals with the design and construction of infrastructure. Civil engineers are responsible for gathering information, finding out design alternatives, develop a design, and construct and manage infrastructure. So we offer 4 years Bachelor's of Engineering in Civil Engineering program, and we do offer Master of Engineering in Civil Engineering by coursework and research. We do offer a PhD by research. Our program caters for 450 undergraduate students, 60 graduate master's students, both by coursework and research mode, and we cater for 40 PhD students as well. So why civil engineering at UKZN? As Prof. Mohamed Mustafa mentioned, that UKZN is one of the top universities in South Africa and ranked under 500 globally. Okay, so we have a website for civil engineering. You are welcome to visit our website, know more about our program. Our program is fully accredited by Engineering Council of South Africa. We do maintain membership with SAICI, South African Institute of Civil Engineers, and our students chapter is very active. This engages our students with more development with SAICI activities. In our program, we have 2 full professors, 3 associate professors, 5 senior lecturers, 4 lecturers, and 2 in-gap lecturers. We are fully we have full complement of staffs with high experienced staff members. In addition, we have emeritus professors and adjunct professors to support our research, and they contribute a lot for teaching and research as well. So our laboratories are well equipped, as Prof. Mustafa mentioned. We have advanced equipments and good laboratory facilities to support our undergraduate teaching and research as well. As we know that our civil engineering program has sub-disciplines: environmental engineering, structural engineering, geotechnical, transportation engineering, water resources engineering. So our staff members we have expertise in these sub-disciplines within civil engineering. So our staff members can do research and supervise students and teach modules in various sub-disciplines within civil engineering. So these are a few research area where our students will get experience in these under supervision of by our staff members. So this is structural engineering. We have various sub-disciplines or research area within this structural engineering. We have transportation engineering, headed by Prof. Mohamed Mustafa, and we have water resources engineering and under various water resources fields, like from water quality, coastal, renewable energy, and engineering hydrology as well. So as we have a fully research capacity, we do collaborate with other organizations. We do receive funding for our research from various organizations to support our research and supervise our graduate and PhD students. So as you join in our program, as this is a 4-year degree, we teach the basic modules from in the first year level, like maths, chemistry, physics, and drawing. And in the second year level, we teach modules like structural analysis, structural design, civil engineering materials, and geology. And we do teach, offer surveying from our land surveying program. In the third year level, we do some advanced module continuing from this our second year level, doing structural analysis, structural design, fluid mechanics, geotechnical engineering, and transportation engineering as well. In the fourth year level, our students will be specialized in environmental engineering, advanced modules like in structures, geotech, and transportation engineering. In their first semester, 4th year, and in the second semester, 4th year level, they do a specialized design and dissertation on one of those 5 areas. So this is very important for our students to demonstrate their competency in civil engineering field. Okay, so we prepare the main objective of this program, or main aim of this program is to build competence for our students to cater for the industry, government agencies, and consultancy firms, or in academia, when the students graduate, they find their job in one of these. After they graduate, they can easily find a career path as a from site engineer to a project manager in various various firms. So they can grow in any industry, right from the entry level to the project manager by achieving or registering successfully with EXA as a professional engineer. So they built on their competency right from the first year. So a long way to do the professional engineering registration. So that will be this program will be a stepping stone for that. And as a last, the graduates can also find research and postgraduate opportunities within our civil engineering program in various fields, from geotechnical engineering, fluids, structures, transport, coastal, and environmental engineering as well. So if they choose an academia as their career path. Okay. Thank you. So this will be followed by a short video and will be followed by a presentation from Ms. Johnson. Thank you. I hand over to the organizer.
Civil engineering at the University of KwaZulu-Natal. We plan, we design, we construct. Civil engineering is concerned with managing the physical infrastructure and facilities needed for the smooth functioning of contemporary society so that the optimal quality of life can be ensured for its people. At UKZN, learn more about structures, transport systems, waste management, water supply systems, and marine works.
UKZN is one of the top-rated universities in South Africa and indeed around the world. And we have well-equipped facilities, laboratories, and staff, highly trained staff. And so we have the capability and capacity to train students to be top civil engineers for the built environment.
Join the School of Engineering at the University of KwaZulu-Natal, inspiring greatness.
Thank you, everybody. The next speaker is a past student, and it is Katelyn Johnson. I hand you over to Katelyn Johnson.
Hi, good evening, everybody. Thank you, Swastika. So I am a past student at UKZN. I studied civil engineering and graduated in 2012. So I will just share with you my journey in my studies and what my career path has become since then. So I'll break down what my experience was like during my degree in civil engineering, the topics that we covered, what we learned, and then I'll show you how my career branched from my undergraduate studies to my postgraduate studies to where I am now. So in the civil engineering program, as Prof Mostafa and Prof Kumarasamy explained, in the first year, we do a lot of advanced science. So it builds on the physics and maths from high school. And in the second year, we do some introduction to civil engineering in terms of materials and design. And then in the third year, it's quite intensive in terms of the theory. And in the fourth year, it's more intensive in terms of application and design. So the major fields that we cover are structural, geotechnical, transportation, environmental, and water engineering. And when we talk about structural engineering, we refer to structural steel and reinforced concrete design. So the design of beams, slabs, columns, foundations, water retaining structures, all of those require some elements of structural design. So whether it be a shopping mall or a high-rise building or even a reservoir, that's where a structural engineer comes in. And then water engineering is quite a fun one. It's my area of specialization. So we work on pipe distribution networks. So as an example, water comes out of your tap, but how does that happen? How does that water get to that point? So there'll be a bulk water network where there's a main pipeline that branches into smaller pipelines that eventually gets to your home. That's because of civil engineers. We also work in the design of open channels for drainage. So often you'll see if you're driving along a freeway, you might see some concreted V drains. That's done by civil engineers. That's also related to flood routing and the design of hydraulic structures such as dams and culverts, as well as general stormwater management within developed areas. And geotechnical engineering involves analyzing soil mechanics, the foundation design, ground stabilization, the design of retaining walls, and soil classification and testing. So again, I'll say if you're driving along the freeway and you quite often see these quite big retaining wall structures that are stabilizing the ground behind them so that they don't collapse onto the road while you're driving, that's what geotechnical engineers do. And environmental engineering involves management of the environment and conservation thereof, and also looks at analyzing social, financial, and legal issues around engineering design and the environment, as well as looking at the impacts of carbon emissions and other climate change impacts. And then wastewater treatment focuses on looking at the design of wastewater treatment plants and waste disposal, and as well as that, we also look at recycling and reducing waste. Then solid waste management is focusing on landfill design, alternative waste disposal methods, and waste management schemes. And then transportation engineering involves the design of pavements. So that's the actual layers of the road that you drive on. And it involves layouts of parking design, any earthworks around that. The geometric design of the road. So why does a road curve in a certain way? As well as traffic analysis and traffic signal timing. So as mentioned before, there are a lot of career options out of these very many sub-disciplines within civil engineering. So you can work in consulting, in industry, you can work in construction, you can work in academics at a university or at a research institute, or you can work for government. So I'll just share with you my path from studying at UKZN in civil engineering. Here you see some very happy pictures of our students in the labs. We've spent quite a bit of time in the lab in our undergrad years, learning to apply the theory that we've learned in all of the various sub-disciplines in the research areas. And I studied from 2009 to 2012, so it was a 4-year degree. And in my final year of studies, I focused on the water field. So my design project was within water engineering, and my research area focused on coastal and environmental engineering, looking at pathogenic pollution of beach waters. So you can see there's a wide range of engineering topics, and when you get into your final year, you decide what areas you like to focus on and streamline your career into. Of course, you can focus on many different aspects. You don't have to focus on one aspect. It's a very multidisciplinary career. So after I graduated, I went to work in consulting, and I did work within the office environment as well as on site. So most of the work I did was within water engineering, water supply. So one of the biggest projects that I worked on was upgrading the bulk water supply to an underdeveloped community in Zululand, where we constructed a series of pipelines as well as reservoirs. And here are just some pictures to show you the experience and how happy and rewarding the career can be. So here I'll just show you. Here's obviously, this was my first little desk in the first office when I started working in consulting, looking all very chuffed with myself with my little blazer. And then I went onto sites, and here's a picture of the reservoir that we worked on constructing. It's about 6 megaliters of water storage. And this is the inside of the reservoir. So there's a lot of structural application here within the reservoir design, apart from the water design. And this is the pipe network that links to the reservoir and provides the community with water from the reservoir. So while I was working in water engineering, at the same time, I was completing my master's, which was continuing in coastal and environmental engineering. But I also discovered a love for the hydrological aspect and hydraulic design. So that led me to want to pursue my studies further. And I left industry work, so I left consulting and site work, and I went back to academia to do my PhD studies in engineering hydrology. So my studies focus on engineering hydrology and the estimation of water resources and management thereof, and studying processes such as precipitation, runoff, and their interaction, and the studying of floods and how to manage them. So it's quite a wide range of research area. And that also led me to go back into academia in terms of wanting to teach. So the work that I teach is related to water engineering. It's fluid mechanics and engineering hydrology application. And what's really fun about an academic career is that you've got a wide range of application of the engineering knowledge. So I'm able to teach students, I'm able to present my research at local and international conferences, and I'm also able to visit other universities and pursue international collaborations. So there's a wide range of career possibilities within an academic career. So thank you, that's my presentation. We hope you'll choose to build your future with us at UKZN.
Thank you for that, Katelyn. That was really insightful. With that, we wrap up with civil engineering and we move on to agricultural engineering, where Prof. Tilahun, who is an academic member of the School of Engineering in the discipline of bioresources, or agricultural engineering at the Pietermaritzburg campus. And he is the program coordinator for agricultural engineering at UKZN. Prof, I hand it over to you.
Okay, thank you very much, Swastika, for the introduction. My name is Workner, Professor of Agricultural and Food Engineering under the School of Engineering, where I am coordinating bioresources engineering. I may be using interchangeably bioresources engineering with agricultural engineering through these highlights. So they are all speaking to the same discipline. So it has been already discussed in terms of definitions and so on by Professor Mostafa. I will try to just give you some more information on what bioresources engineering is. So we need to start with some questions. I draw some of the questions like who needs water to survive? I think every one of us needs water to survive. Living things needs water to survive, plants, animals, human, and so on and so forth. Who needs food to survive? I think similar to the level of the need for water, food is also very important. Living things really needs either food, feeds, or nutrition to grow. And who needs, again, clothes? We need clothes, especially in the modern society. We like the natural environment. So agricultural engineering or bioresources engineering deals with solving problems of this nature using basic principles that comes from other engineering disciplines. So some of the examples of biological resources that we need to work for, engineer the environment for, to grow, to harvest, to store, to process, and so on and so forth, are plants and animals. Plants and animals, commercial forestries are resources, rivers are resources, and dams are resources again. Commercial and traditional agriculture is again a resource where we actually get food, fibers, and so on and so forth, materials for industrial purposes. And the game parks and the farms are again another resource that needs attention, and that needs specialization, expertise to develop environments around it, engineer environments around it to grow, to give you a good yield, and so on. So lists of bioresources engineering in terms of specialization may include the following, such as engineering hydrology. You might have heard of hydrology as a science, but engineering hydrology, what specialization it is. You see dams holding water, main channels transporting, conveying water from sources to farms, and so on. Ecological engineering, land use engineering, agricultural machinery engineering. You might have already heard tractors, combine harvesters, trailers, mowers, and the tools associated with it as required in different operations, from land preparation to harvesting, storing materials. Engineering for food and fiber production is another specialty area of bioresources engineering. Structures and controlled environments for plant and animal production is another very important. In fact, this area is of the future. As population is growing, as resources are depleting, as land become scarce, we are leading to precision agriculture where we engineer our environment and develop, grow plants, animals, and so on and so forth in small plots. So structures and controlled environments engineering for plants and animals will remain to be one of the future. That's why when we talk about NASA research, they talk about actually how to grow plants in an engineered environment, even if we are away from the Earth. Leave it alone on the Earth, there are quite ample dry lands, deserts, and so on and so forth. It is possible to grow plants sufficient to feed human population as well as animals, wild animals, and so on. Engineering for food processing, you might have seen already when you walk into supermarket, you will see packed products that do not deteriorate on an ambient environment on the shelf. You will see refrigerated fresh produce somewhere, and again refrigerated animal products, dairy products in different shelves, and so on and so forth. So ag engineer or bioresources engineering will lead you to specialization in engineering for food processing. So generally, the undergraduate program will actually enable you to acquire knowledge or skill on how to do things actually as associated with each one of these. So you will take a route once you are through with your undergraduate studies to either of these, engineering fields to create business or to go for job opportunity. All right. So now let's have a quick look at engineering hydrology. The engineering hydrology obviously deals with the application of principles of engineering to solve problems related to water. So we call it engineering hydrology. It is one of the popular fields and one of actually highly lucrative field in terms of job opportunity in South Africa, as well as across actually in the continent and elsewhere, as water is becoming one of the big challenge in the current century and even in the future. So dams, rivers, floods, and droughts are actually related to this field, and the problem solving needs is actually also associated with designing hydraulic structures. Water in South Africa is one of a typical agency where implementation of the 1998 Water Act is actually being implemented to conserve water, to harvest water, to transport water to the field, to grow plants and animals, and management and efficient use of water resources also another area of speciality within this sub-specialization of agricultural or bioresources engineering. All right, you can see how much the flood is really affecting places. One of the flood problems that we experienced recently in our own region is a typical example of the need for expertise in engineering hydrology. Okay, ecological engineering is another important area which is of high interest today. Demand as industrialization progresses, pollution comes in, and forestation comes in, wildlife being affected, and so on and so forth. So to help manage really the complex interactions between living things and the technology development around us, we need expertise in areas of ecological engineering. Use of computers, GIS, geographic information systems, databases, and remote sensing, which is part of the fourth industrial revolution today, plays a major role actually in many of the expertise areas of bioresources engineering, in hydrology, engineering hydrology, ecological engineering, environmental engineering, and so on and so forth. These tools are of high importance. So we train you on how to use some of the appropriate and relevant computer tools, programs, and of course the GIS techniques, database use, and and remote sensing on how to solve the real problems out there. Impact assessment, of course, is part of the ecological engineering activities where one can specialize and make a career out of it. And the bioresources engineers work with scientists to measure the predict and also predict ecosystems processes and so on. So remember, bioresource engineering undergraduate will also contain modules that leads to develop your knowledge in areas of ecological engineer to the level that will make your niche and then proceed with it as a career field. Okay, the land use engineering is another part. As you see, land preparation is one aspect of development in agricultural sector. So we will be teaching you or training you towards actually acquiring some technical knowledges that enable you to work as a land use engineer in the field. So precision and the sustainable agriculture today starts with you understanding the land and prepare the land, of course, for the required purpose or development, for animal production, for plant production, for human activity, other human activities, environmental protection, and so on and so forth. So here is actually really where the fourth industrial revolution is coming in as part of the studies that you will be exposed to in an undergraduate program of ag engineering. So erosion prevention, ahead of estimating, predicting actually what is happening in the next few years or decades, can be done here with the knowledge that you will be acquiring here. Land reclamation and so on. So the other is aspect is the soil erosion. Soil erosion is a problem, of course, within even our own country, South Africa. You can see what the land in some places looks like. Rail erosion development or gully erosion development requiring permanent structure or biological measures. So when it comes to permanent structure, it requires the knowledge where engineers need to involve design, develop structure, and of course be able to reduce the advancement of soil movement from place to where it is not really necessary. So it's very important area with high demand today in terms of job opportunity, even in South Africa, as well as elsewhere in the African continent. Okay. So engineering for food production and transport logistics is very important. It is an easy area in some cases where people actually advance their career or become entrepreneur, investors and so on and so forth. So, now you can see machineries are very important everywhere in each unit operations, as we see, for production, for land preparation, for planting, for sowing, or planting, or for cultivation, or for harvesting, for transportation from the field to the store site, and also actually moving material from place to place on land or in water, or even in flights and so on and so forth, requires the knowledge of agricultural engineers with interest in food production and the transportation. A transportation logistic itself is of a huge actually opportunity for agricultural engineers to become entrepreneurs. So the knowledge of how to maintain products without deterioration after harvest, maybe for 30 days, when the price actually jumps maybe by few rounds, leads to quite a lot of return and so on. So you can see machineries on the field, cultivating, combined harvesters, as you can see, machineries for transportation, and park house, for instance, material movement in park house. All that is actually part of the knowledge area where agri-engineers are really practices today worldwide. Okay, so machines to produce food and fodder, again, as I have discussed, combined harvesters, I think it is self-explanatory. As you see cultivators further down on your right side, and you will see sugarcane actually packing and transportation systems, maize harvester, as you can see, and so on and so forth. So we are dealing with these all. There are modules which are specializing actually in these particular areas, equipping you with the technical and the soft side of knowledge that you require to really advance your future as a career, as academics or as researchers or as industrialists actually, or even as a practitioner engineers actually out there. Okay, so engineering in forestry is another very important area, as you can see, where actually growing forestry by itself is forest engineering as one of the specialty in agricultural engineering. And forest machinery is another area which is actually associated with forest harvesting, or forest processing, say into timbers and so on and so. So this is one of the very decorative area also that we consider as part of the module in agricultural engineering. So precision agriculture, post-industrial revolution, you might have heard that many actually talks about post-industrial revolution, the use of current technology to advance the efficiency of agriculture, agricultural production, animal plant production, processing, marketing, and so on and so forth. So this area, I think, is an area which will be advances productivity of food for the ever-increasing world population in the future. Land is becoming scarce, water is becoming very scarce and challenging. And with that in mind, I think we see a future where precision agriculture is going to take over, in most cases, the conventional farming. Okay, so you will be introduced to these technologies where use of drone actually, and also controlled environment, precise control of environment for specific plants, for specific animals, based on their requirement, physiology, is what agricultural engineers are equipped with and interested in. Okay, and then design of irrigation systems. You might have already heard there are different types of irrigation system: a furrow type irrigation system, drip type, the micro irrigation system, mobile type of irrigation system. So we do have modules which are specializing actually in this particular field, aiming at producing an engineer who can design irrigation system, install, actually supervise irrigation systems, and also evaluate performance of irrigation system. So this is very important area in the recent times as well. The structure and the controlled environments for plant and animals, which is very important. As you see, vegetables growing in house. Okay, why not on the building in the future? This is precision agriculture. We are leading to this future, and definitely this is the knowledge which is going to be really taking us further in the next few decades. Okay, storage structure where controlled environments are required, piggeries, poultry farms, and so on and so forth. So engineering for food production or food processing is again one of the specialty in agricultural engineering. It is well known, in fact, most of engineers in Northern America and Europe actually goes into this specialization. They come to the university to do postgraduate study after bioresource undergraduate program to carry on with the entrepreneur, actually going back to their own farm and create their own business. This is one of the easiest, actually, also engineering field where people actually really go into entrepreneurship and create their own business. Okay, so engineering for food processing actually leads to all these products. I think at the end of this degree, obviously you should be able to establish a small scale, even if budget capital is not there, tomato processor or tomato sauce or mango jams, you know, and so on and so forth, or extract biochemicals from plants and so on. So this is one of the area for in bioresources engineering. We have actually modules which are focusing directly towards this field. Okay, so in closing, bioresource engineering within the environment, there are many fields of expertise to get involved with. Work opportunities are very ample. Actually, government and the private sectors are open. Even within Pietermaritzburg or Durban, you will find quite successful agricultural engineers in terms of consulting in many areas of the agri-engineering fields that I have mentioned. And the bursaries are sometimes available from departments. The degree is actually fully accredited with EXA. And in fact, this is the only agricultural engineering program which is accredited by EXA. And hence, by default, as Prof. Mohamed mentioned in Washington Accord and Dublin Accord, it is in engineering accreditation. So you can move everywhere worldwide, your degree will be accredited. So now we are also working very close with South African Institute of Agricultural Engineers. And at the end of your degree, in the 4th year, your project will be actually presented at the South African Institute of Agricultural Engineers. They encourage you, and throughout your study period from 1st year to 4th year, there are quite a number of events, including induction into agricultural engineering, which is actually run by South African Institute of Agricultural Engineers. Probably I would finish my part here. Thank you so much. And if you need any further information, please contact us. Our office is in Pietermaritzburg campus in a building called Robbie Saunders Building, 2nd floor. You will find myself or Ms. Natasha Manivalu. Thank you very much for listening anytime. Okay, with that, I think I will introduce one of our current academic staff and our students also in the past from the same discipline. Ms. Khutadzo is one of agricultural engineering doctoral students working at the UKZN as a new generation of academic program. And she's lecturer at the School of Engineering and specifically in the discipline of bioresources engineering, who has over 7 years of experience in agricultural engineering research and development. And she has 2 years of experience in teaching, and she has actually successfully supervising students in their project. So, and I also would like to invite you to watch a video recording about agricultural engineering at the University of KwaZulu-Natal once you have some highlights from Ms. Khutadzo. Ms. Khutadzo, welcome.
Thank you. Hope everyone can see me. My name is Khutadzo Mogodo, and I am a new generation of academics lecturer at the University of KwaZulu-Natal. So it was mentioned under the bioresources engineering discipline. I am a candidate engineer registered with EXA. So I'll just take you through my journey as an agricultural engineer after graduation. So I graduated in 2013 with my BSc degree, and immediately in 2013 I got employed and at an agricultural research institution. As it was mentioned, I think in the first presentation by our academic leader, he mentioned that agricultural research institutions are one of the key employers for engineers as well. So I've been working in research, and I worked as a junior researcher from 2013 until 2019. And most of my work was around research and development of technologies around agricultural engineering. In 2014, I registered for my master's at the University of KwaZulu-Natal. And whilst I was doing that, I was also working full-time. And in my work, I worked in most of my work, I was involved in different fields of agriculture. I was exposed extensively to quite a lot of fields of agriculture. I was exposed to the renewable energy side of it, where I was working in solar drying, which became my Master's of Engineering project. I also worked on biogas. I also led a construction project, and I was also involved in agri-processing technology. That is research and development of technologies involved there. So in 2019, I started my PhD, and that was when my career evolved from not only research, and I started working as a lecturer as well, and that obviously involves some teaching and supervising research. What I learned in my journey as an agricultural engineer is that it is very diverse. The field is very, in the research side of it, I found it very diverse, because one day I'm a scientist, I found myself doing laboratory experiment. I found that with my interest was, just before I go further, my interest was in the food engineering side of it. So I found that technology doesn't work alone. So you need to at least have an idea of the consequence of technology that is developed. So that is where you find me in a laboratory where I was looking at the impact of drying technology. Specifically, I look at a particular solar drying technology, and I was looking at how it affects the food. The drying process affected the food. I also had some exposure to engineering, design, and construction in the same company as I was when I started off my career. And this is where I started off supervising construction projects, but at the end, I had my own project where I was leading a construction project in Gauteng province, and was involved in the design and also supervising the process of construction. In that process, I was also exposed to municipal processes and also how to initiate contracts with different contractors and project collaborators. I've also learned to be an author whilst in my journey in the research field. I learned how to publish my research results. I learned how to conduct or to write proposals. In my career, I've written a proposal that was awarded by the New Zealand High Commission as a lead applicant. I've also been a participant to proposals where I was not a lead applicant. So I've got quite a lot of experience in writing proposals that are funded by different organizations, which includes municipalities and also overseas or international organizations. I've also written technical documents. I'll show you a quite interesting one that I worked on. And I've also worked in community engagement, and that for me was the interesting part about the being an agricultural engineer, where I would go and see what was happening in the field. In most instances, when I was working in a research institutions, I would work with rural farmers or rural stakeholders, and that is where I was either looking for a particular problem, investigating about problem for feasibility study purposes, or I would be working with a beneficiary of a particular technology. And what became also interesting was the traveling ventures that came with being a researcher in the field of agricultural engineering. That exposed me to international travel. That was looking to present my work or my research. And that is where I got exposed to different type of technologies that were in the field or they developed specifically from the developed countries. I've also worked as a statistician. I found myself analyzing data. It forms a very significant part of my journey as a researcher as well. And with the various fields that have been mentioned in this presentation or in the previous presentation by Prof. Workney, I have worked, currently I'm mostly working in food engineering, and that is what my field is, or my preferred field is, after working in such diversity in the journey. So I've chosen to work in the food engineering field, but I've been exposed to irrigation engineering. I've done vacation work since I was a student. So I was exposed a lot to irrigation engineering, or when I was a student. I've also done a bit of structures, and as I mentioned, I've done renewable energy. So just a bit of a picture of what I've done. As you can see, I've engaged with communities. I've been in the lab. I have presented in a stage with international people, or in an international stage. I've also been involved in construction and producing a very significant report. I was part of it. It was a multidisciplinary collaboration, and that was for the German corporation in South Africa. So what I've also learned, or what I've deduced from working as an agricultural engineer, is that you become quite a diverse person as well, and you realize that in the field of engineering, collaborations are very important. And in my collaborations, currently with my PhD, I'm collaborating with a food scientist. I'm also collaborating with a plant breeder. I also collaborated with animal scientists, with architects, and most importantly in construction. I've also worked with soil scientists, I've worked with statisticians and chemical engineers. This is what I've worked with throughout my career, and I've realized that the diversity of this field requires mostly a multidisciplinary network, and that is what has really helped improve my perspective, and also improved my knowledge of the field. With that said, that is it from me. Thank you very much.
Thank you so much, Khutadzo. I'm going to just share the video on agricultural engineering.
Bioresources Engineering at the University of KwaZulu-Natal. We grow, we build, we process. Bioresources Engineering integrates scientific principles and engineering practice to solve practical problems in the production and processing of food, fiber, feed, and fuels. Bioresources Engineering connects the living world of plants, soil, water, and animals with the technology of engineering. At UKZN, learn more about irrigation, agro-processing, food and fiber production, structures and controlled environments, and water resource management.
The reason why students should study at the University of KwaZulu-Natal is that we are the only tertiary institute in South Africa that offers an accredited agricultural engineering degree. And now, more than ever, more females are venturing into this previously male-dominated field.
Join the School of Engineering at the University of KwaZulu-Natal, inspiring greatness.
Thank you. We'll now move on to land surveying. Dr. Mulemwa Akombelwa is the Program Director for the Land Surveying Program, and he will now address you. Dr. Akombelwa.
Thank you. Good evening, everyone. I'd like to welcome you to a presentation on land surveying at UKZN. So I'm the program coordinator for the land surveying program. And I just want to give you a brief overview of what land surveying is and what the various branches of land surveying are. So land surveying is also known as geomatics. Now, the question is, why land surveying? So today we'll look at what land surveying is and the importance of doing land surveying. So all the presenters that have presented so far, the civil engineers, the agricultural engineers, have all shown that everything they do is done on land. And whatever they do needs to be located somewhere. And in order for any building to be located, you need land surveying. For a road to be constructed, you need land surveyors. But let's look at what land surveying involves. There are several branches to land surveying, and I'll just name a few here, which form the main branches of land surveying. We have what is known as cadastral surveying, which involves property surveying. So if you're going to buy a house, or you're going to buy a flat, or maybe you want to have your plot of land surveyed, so that type of surveying is what is known as cadastral surveying. We also have what is known as engineering surveying, which, as the name implies, is involved mainly for engineering projects, engineering works. There is also hydrographic surveying, which is related to surveying on the water, or trying to determine trying to determine what the bottom of a water body would be like. So hydrographic surveying is that component. And then there's geodesy, which involves determining the shape of the earth. And this is important because it's the basis for every type of surveying that we do. Then there's remote sensing, which uses satellites to tell us the state of what the earth is. For instance, for climate change, climate monitoring, remote sensing is what is used. And also, we've got photogrammetry. This is where we use aircraft and also drones to take aerial pictures of an area, and we create maps out of that. And then there's GIS, which is used for combining the various kinds of information that are collected from surveying. So all in all, this is what land surveying or geomatics is. In fact, recently, there's been a push to rename land surveying as geospatial engineering. And this is a global push. So you can see from here, or you will see from here, why land surveying is actually sitting with civil engineering. We are closely associated. So some of the various aspects of land surveying, as I mentioned, are engineering surveys. So these can be used, for instance, on construction sites, even for monitoring existing buildings. So here is an example here where we have our students doing some precise engineering surveying within a pre-existing building. So these are some of the practicals that students are exposed to. Ours is a 4-year degree, and within that 4-year degree, just like civil engineering, the first year deals mostly with the science subjects, and then students are introduced to basic surveying concepts. And then in the second year, the surveying concepts are increased, and by the third year, they are now beginning to specialize in the various areas of surveying. And fourth year, they enhance most of the special skills that they have learned. So another aspect is photogrammetry, which I mentioned. And with photogrammetry, lately, there's been a lot of drones which are used. So here you can see a drone just being fitted with the camera just before launching it, so that it can be used to take aerial photographs. And these are what are used when students go for camps, and also some practicals here on the campus at the university. So this aspect of photogrammetry is very useful, very important. So you can see here, this drone is carrying a camera, but sometimes they can carry different equipment, which will measure different things. So this is an important aspect of land surveying or geomatics. So we have what is known as laser scanning, and here students are having a go at using a laser scanner. So what this is basically collecting information of features that exist as they are. So these have been used, for instance, in heritage mapping projects, such as which are then used to create 3D models of those once the data is collected. So these are quite, this aspect of surveying is very, very important. So in this exercise, you can see here, the students will collect information about some of the vegetation behind there, like the trees, the structures there. And on this side of the camera, although not shown, there are some buildings which they will be scanning, and then they go and process that information when they get back to the lab. Remote sensing is an important aspect of the program, and this utilizes information collected from satellites. So we collect satellite imagery, and we use it to analyze it for different aspects of the environment. So it could be that maybe you could be monitoring invasive species of land, or trying to see the various places which maybe are difficult to access, but cover a large area. So for different aspects, remote sensing is used for this aspect. And so there are various satellites which are used for that application. We also deal with GPS surveying, and for that we use data collected from satellites. We have receivers here which access these satellites, and we get information which we then use for various aspects. So GPS is actually widespread. I know all of you have got mobile phones, and on your mobile phones, you've got Google Maps. So Google Maps basically uses GPS to give you a location of where you are. And at the end of this presentation, I'll show you some of the applications which rely on this technology, which is central to surveying. So here you can see some of the GPS equipment, and we have here some of our students working with the equipment that we have, doing various surveys using the GPS equipment. I'm sure you have seen this equipment around, maybe on roads, or maybe surveying different parts, maybe of property. But this is just one application of GPS surveying. It is also used for navigation, and we teach our students all that. It's all part of the curriculum that is offered here in the land surveying program. Another important aspect of the program is hydrographic surveying. And with hydrographic surveying, our students also go out for practicals. And you can see here, this was at Midma Dam, and we use the boat that's owned by the university, and this is from the biology research unit. So with this boat, we were showing students various methods of data collection. So we also have a research project for undersea heritage mapping that is currently ongoing, and it uses hydrographic surveying techniques. So here is some of the equipment that was being used to collect some of the data just offshore here in Durban. So the project is just up north on the coast, on the KZN coastline. But this is some of the data that was collected just offshore. So hydrographic surveying is an important aspect of the program. Geodesy is key to the program. It's key to surveying because it's used to define the shape and size of the Earth, and also to define our reference coordinate system. So here you can see some of the geodetic equipment that exists in the country. We do have collaboration with the South African South African Radio Astronomic Observatory, which is at Hartbeespoort. And what I'm showing you here is the system that defines the origin of the coordinates, the South African coordinate system that we use. So if you want to know where you are in South Africa, it's all referenced to this station here. So it's a very key and very important aspect of surveying. So we don't just work in isolation. We do have our collaborations with such institutions, which are quite important. So in fact, the origin of the code of the South African coordinate system is not with this GPS receiver, but on the white antenna that is facing upwards. The center of that antenna that is facing upwards, that radio telescope there, defines the center of the coordinate system in South Africa. So throughout the program, as we have mentioned, we do have field trips where students actually are active. They're given activities to pursue during the field camp. And we have this annually. And so when they go out to do their work, the students collect data and come back to the office, and then are able to produce maps from there. these are skills which they then take out to go and apply when they go out to industry. So what you see, for instance, in the boat there, those are our students who just finished collecting data on the dam. So we also have once in a while presentations from industry where they come to showcase some of the latest equipment. So this was just a few weeks ago with one of our industry partners. And this keeps the students up to date with some of the new developments. And then they also get a chance to familiarize themselves with that equipment, do some processing with that equipment. So we also have research, as I have mentioned, about collaboration. So in the research aspects, this is mainly for postgraduate studies. Our students interact with the industry where they do projects which are industry-based. And also some of the final year projects we get from industry to address certain different problems. So land surveying here at the UKZN is a very important program. And the program is accredited by the South African Geomatics Council. And so when our students graduate, they can then begin their articles, which take about 2 years. And once they complete those, then they become registered geomatics professionals. And our graduates are employed in various organizations in municipalities, in government, like Department of Agriculture, Rural Development, various the municipalities, and in the private sector as well. And some of them, after working for a while, even form their own companies. So there are a lot of opportunities that exist in surveying at the moment. In terms of applications, you may wonder where the applications of surveying are. So geomatics has changed how we live, in that with the coming of GPS, so using Google Maps, business models have been set which use satellite technology to know where we are. So if you want to, excuse me, if you want to, if you want to book a taxi, for instance, you want to find out where you're going, or you want to book a package that will be delivered to your household. This is the everything is based on surveying applications. So the applications of surveying are many, from scientific applications. You can go and work in government, you can work in the private sector, and also even in application industries. So land surveying is very, very important. Prof Wokne talked about surveying being useful he talked about precision agriculture. So for precision agriculture, it means you should precisely know where you're going to plant and so forth. So we give that information. We use GPS for that information. Prof Mostafa at the start talked about civil engineering, constructing bridges, roads, houses. In order to do all that, you need a surveyor to show you where you're going to build, because we prepare the maps. And also when construction starts, in order to control the construction, if it's a skyscraper, you need surveyors to tell you that, well, you're constructing this upwards, or you are tilted, you need to make corrections here, or whatever. Surveyors are all involved in the whole process. So we are part of the whole process. We are not separate. but we have a lot of various applications. And so if you would like to come and study land surveying, this is the place to come to. So with that, I'd like to thank you very much. And I would like to then invite you to a short video presentation about land surveying. And also after that, a short presentation from one of our former students, Mr. Thando Nqasha, and he is now a junior lecturer on the NGAP, and he will talk about his experiences as a student here and where he is now. Thank you very much.
Land surveying at the University of KwaZulu-Natal. We survey, we plan, we strategize. Land surveying deals with the field of geomatics, which is a discipline that focuses on the acquisition, processing, management, presentation, and dissemination of information about the Earth and features with a fixed location on the Earth's surface. At UKZN, learn more about geographical information systems, land information systems, global positioning systems, land development and management, and applied computing.
We are a unique department because we are part of an institution that is promoting African scholarship. We therefore are encouraging students or potential students wishing to study land surveying to come and join us. We've got a lot of resources to offer.
Join the School of Engineering at the University of KwaZulu-Natal, inspiring greatness.
Good day, everyone.
Thank you.
Okay, so Sky, may proceed.
Yes, thank you.
Okay, good day, everyone. My name is Thando Nqasha. I'm here to share my experiences as a past student from the land surveying department. So I completed my BSc and MSc in land surveying here at University of KwaZulu-Natal. Currently, I'm working as a junior lecturer here. I'm also employed in industry in geophysics. I'm working there as a constructor. I'm also undertaking my PhD studies. So during my undergrad studies in land surveying, what the degree focuses mostly on is surveying and mapping, 2D and 3D spatial modeling and visualization, automation and research. Under surveying and mapping, you'll be introduced to different surveying equipments. So we've got this equipment here, which is a station. Most of us, even myself, I thought this was a camera, but it's far from it. Use this equipment to measure angles and directions, which will give you coordinates, which are useful for civil engineers and architecture. Here we've got a GPS, which Akombelwa is introduced. This is the GPS. It's very accurate compared to your cell phone GPS. Your cell phone GPS is roughly 8 meters accurate, and this one it's millimeters of accuracy. So we use this for sensitive stuff, for example, land demarcation. And here we've got this underwater scanner. We use this scanner to to model the underwater features. So here we're testing this equipment at the swimming pool here at KZN Howard College. And here we're using our single beam echo sounder to actually get the depth of this dam here. This is Midma Dam in PNB. And this is our DJI Phantom 3. We use this to collect aerial photographs, which are used for various applications. And we use all those equipment to collect 2D and 3D data. Once we collect the data, we can like model it and visualize it in different ways. So from this diagram, we can see this is like demarcation of property boundaries. So these are how your properties are marked. We use the surveying equipment which are high accurate. They are like in millimeters of accuracy to mark your property boundaries. And if you can use a cell phone, like if you can use your cell phone to map these, like you can cause like a lot of disruptions because your cell phone like has 5 meters accuracy. So like you might end up 5 meters inside your neighbor's yard or 5 meters inside your yard. And we also use drones to capture aerial photographs, which we use to construct orthophotos. This is an example of how we do that. So a drone will fly on the sky, and then it will capture photographs along a certain path. And then in the end, like we'll select type points within those photographs, and we'll be able to construct aerial photo. And this is a bathymetric map. We get this, it's a 2D bathymetric map. So we get this by using our single beam echo sounder, which gives us depth. So this gives you your depth below mean sea level. And these are 3D. This one is a 3D model of the shipwreck, submerged shipwreck. So this shipwreck is underwater. The only way that we can actually get the model of this shipwreck is using our multi-beam echo sounder. And I believe in South Africa we are the only university which has that scanner. And here we use our terrestrial laser scanner, or we can even use structure from motion to construct these 3D point clouds, which are also used for various applications. So following collecting the data, we have to extract features on our data. If you have to extract features on this image, like it will take you like a really long time. So we have to like develop codes that will enable us to extract features in a minimal time. So as you can see here, like here it extracted buildings. So there's a code for that. Like you have to like check the shape, and then you write a code, and then like once you write the code, it will give you like it will mark all your buildings within here. And this also is similar thing, but then this is now done in the 3D point cloud. So this is how we do the automation. So this is what I've learned also, like in my undergrad studies at KZN, and it's also very useful in the field. So during my time as a student at KZN, I've been involved in a couple of projects. So one project was Seyoum seismic risk and rockfall. So here we have this large granite dome here. So this dome exfoliated. As a result, it caused seismic activity, which means like there was shaking of the ground. That was followed with the falling of rocks. So we had to like do a seismic risk in this area. In 2018, we also had to go and check in KZN in the Bongwana Falls. There was some shaking there, so we had to do some intensity data collection. And also I've been involved in the underwater heritage mapping. So during this pool visit, we were testing the equipment. And then I'm also involved in the KZN seismic station. So for this one, we want to set up the seismic station so that whenever there's an earthquake around KZN, we can be able to capture it on this seismic station. You might recall that I think last year in May, most people felt shaking around Durban, but then that wasn't captured because most of the seismic stations are very far from Durban. So once this station is up and running, we'll be able to capture all those seismic activities. So yeah, that was my experience as a UKZN student. Thank you so much.
Thank you so much, Thando. And thank you so much for everyone who attended today. We are very pleased that you spent like a couple of hours listening to our presentations, and looking forward to seeing you all around at Howard College and Pietermaritzburg next year. The last thing we want to leave you with before we close this meeting is a video about the research activities running at the 3 programs we have at the School of Engineering. So Swastika will be playing a 7-minute video. Please watch and enjoy, and we wish you all a very peaceful night, and looking forward to seeing you. Thank you. Bye-bye.
Thank you, everyone.
The research in my cluster is a little bit diverse because it's a quite large cluster with 4 programs. So we have various research activities. Because of the diversity of the research, the value, although high, it differs in its impact. The main research entities are in civil engineering and bioresources engineering. Not to forget mentioning the research happening in the land surveying and construction studies as well. The Transportation Research Group is a multidisciplinary group where we look at different aspects of transportation. I can mention 2 very important ones. The first one is trying to introduce a new design for traffic lights, while the other one is introduction of asphalt and pavement materials which are made of recycled or byproducts, and these are normally much cheaper than what is in the market already.
This is the Environmental Engineering Laboratory based in the Department of Civil Engineering. We are part of the South African Chair in Waste and Climate Change that is based here at UKZN. A lot of our innovative projects revolve around the use of waste or diverting waste from landfill and using that waste in projects that produce value-added products. Some of the projects we're involved in is alternate building materials, where we use waste products such as biochar, waste tires, and organic waste in construction materials. One of our very interesting projects that we're involved in is the Neptune project, which is being used to create awareness about waste, in particular plastic waste. And the idea behind the project is to use plastic waste in the creation and promotion of art. Some of our external collaborators and funders include Saneri, Lotto, TRIP, DTI, DSW, and NRF. These collaborators and funders have helped the advancement of many of these projects, as well as allowed capacity building in terms of research outputs, as well as PhDs, masters, and undergrad students that have graduated.
So this is the Environmental Fluid Mechanics Lab. Here we look at trying to address complex engineering flows and develop design solutions for them. So projects that we're working on currently are the hydrodynamics underneath breaking waves to look at how sediment moves on or offshore along our coastline. We have some renewable energy projects where we are trying to produce biofuel from wastewater discharges and flexible tubes, as well as flying kites in the Agulhas current to extract energy from the Agulhas current. The research here is primarily sponsored by eThekwini Research Chair Funds. The results of this research are used directly in shore protection along specifically our Durban coastline, making sure that there's sand on the beaches or figuring out why there isn't sand on the beaches.
Our group is the Structural Engineering and Computational Mechanics group. Recently we completed 2 studies. The first was related to the structural evaluation of megalithic monuments in Malta. These are monuments that have been constructed the 4th millennium before Christ. So they are in the UNESCO's World Heritage List, and we completed a study and we published in a top engineering journal our results. And the second study was related to graphene and non-composite materials. So the materials and structures of the past and the materials and structures of the future.
Bioresources Engineering at UKZN have been working with the forestry industry in South Africa and collaborating with the Institute for Commercial Forestry Research, Forestry South Africa and the Department of Science and Technology to provide affordable and appropriate mechanical assistance to small-scale timber farmers, and thus reduce their hard manual labour required when harvesting their timber and also improve their productivity during harvest. The Mugeni Water Chair has been involved in supporting a number of research projects which range from the role of ecological infrastructure in securing water supply in the Mugeni catchment, research on fish behaviour monitoring techniques, development of a predictive mass balance model of chlorine and flocculant consumption in water treatment systems, development of a predictive mathematical model of revising and updating techniques in water treatment, to leading the National Flood Studies Program in South Africa, which is revising and updating techniques for flood estimation in the country.
The open-ended, naturally ventilated greenhouse does not need external energy to run. However, in terms of temperature and relative humidity management, it works perfectly, and there is no significant differences between productivity between this greenhouse and that which requires electricity grid to run. In one of our recent research, we integrated solar energy into low-cost evaporative cooling technology. So now the system is running totally with solar energy. The technology can be implemented in a remote area outside electricity grid.
This is a master's level project. We're looking at vertical farming and soilless media culture. So we want to see the performance of vertical farming and soilless media, but also comparing it to the productivity of ground-based or traditional growing methods. We're looking to see the productivity, water use efficiencies, things like that. We're running with artificial light and with natural light, and then we also have 2 different nutrient concentrations to see the nutrient use efficiencies as well. We're hoping that this will help revolutionize farming and help people with small-scale agriculture to be more productive on their land.
Thank you everybody for joining us, and good evening.
Yes, thank you very much.